The logarithm is the inverse of an exponential function. So if I gave you this problem, 2 to the x equals 6, and I asked you, find x, solve for x, tell me exactly what number x is. Well, we know that 2 to the 4th, 2 squared is 4. We know that 2 to the 3rd is 8. So we would know that that x would have to be something between 2 or 3, but we'd have to guess. We'd have to think maybe it's 2.5, maybe it's 2.4, and we'd have to guess and check to figure it out. With logarithms, we can find out exactly what that x value is by doing the log base 2 of 6, and that would tell us the x. Now, when you first look at this, it's going to look a little bit foreign because you have never seen logarithms before. This is something that a lot of times in Algebra 2, we're going back over things that we learned in Algebra 1. This is something you have never seen before. Here's the definition of a logarithm with base b. The log base b of x equals y, and I'm going to write down here log base b of x equals y. This is the same as b raised to the y equals x. I call this the logride. This is how I translate from logarithmic form to exponential form. Put your pencil on the base, b, and go, woo! The woo is mandatory. That's my story, and I'm sticking to it. If you look at that little curly Q that I just drew, it connects b, y, and then x. Notice the order of the exponential version of this. B to the y equals x. That logride shows you the order that you would write those letters in exponential form. You can also use the logride to go backwards from exponential form to logarithmic. Woo! Log base b of x equals y. So it shows you the order that you're supposed to put those things in logarithmic or exponential form. When you're writing log base b of x, notice that log x equals y, that's all on the same line, the same size. The b, the base, is slightly smaller and below in subscript. Okay, first thing we're going to do is just practice translating from logarithmic to exponential form and from exponential to logarithmic form. So in number 1, I've got log base 3 of 9 equals 2. Start at the base 3 and draw a little curly Q. Woo! Let me hear your woos. We'll work on it. Okay, so the first number that we touched is 3. We're writing this in exponential form, so the next number we're going to write is the exponent. The logride tells us that that number is going to be 2, and then equals 9. 3 squared equals 9. Does 3 squared equal 9? Yes, it does. The next one, start at the 8, and woo! 8 raised to the 0 equals 1. That one actually might help you on your assignment today. Just saying. Okay. And this last one, start at the base 5, go around to the other side of the equal sign, and then back around. 5 raised to the negative 2 equals the fraction 1/25. If you want to keep that 1/25 in parentheses, that's totally fine. We also need to make sure we can go from exponential form to logarithmic form. You start with the base. The base is the number raised to the exponent, and woo! We're rewriting this as a log, so we write log. That first number is the base, so it's slightly below in subscript. The next number that the logride touches is 36, so we write 36 equals 2. Some people have found this to be helpful. Log base answer equals exponent. And I've written this on the board as well to help you. But this just shows you that the logarithmic form, the exponent, ends up being on the other side of the equal sign. So on number 5, we start with the 16 and we go, woo! How many of the people watching my video are totally tired of me going, woo, at this point? Yep, they're tired of it. So log, the first number is 16, so we put the base of 16 in the subscript. The next number that we touch is 1/16. You can put that in parentheses to make it a little bit easier. Equals the exponent of -1. Why don't you try number 6 on your own? Number 6, you should have gotten log base 125 of 25 equals 2/3. How'd you do? Good? Okay. In numbers 7, 8, and 9, they want you to evaluate without using a calculator. So they want you to basically guess what would the exponent be. If I put equals x and then changed forms, this would be 3 to the x equals 81. So what exponent, when you raise 3 to it, do you get 81? 3 squared is 9. 3 to the third is 27. If you try 3 to the fourth, you would get 81. So the answer here is 4. Log base 3 of 81 equals 4. Now, on these, they want you to kind of guess and check to kind of get an idea of what logs equal. So log base 2 of 16 equals the exponent, 2 to the whatever is 16. But there is a way to calculate these using your calculator, and I want to teach you that so that you are able to do these in your calculator. We're kind of going to jump forward to the common logarithms. The LOG button on your calculator is base 10. When you see the LOG button on your calculator, it is really log base 10 of that number. But log base 10 is used so frequently that they decided to put that button on your calculator. So find the LOG button on your calculator and push that button and type in 5. You should get 0.699 if we round it to 3 places. The other log button on your calculator is the LN button. LN, I'm going to write ln of x is the same as log base e of x. ln means the natural log, the log that uses the natural base. So anytime you see ln, it's really base e. If you see log with no base shown, you know that it's base 10. If you see ln, you know that it's base e. But to do ln of 0.1, you punch the ln button on your calculator, type in 0.1. If you get negative 2.303, if we round it to 3 places after the decimal, you punch that into your calculator correctly. So if we've got plain log or plain ln, we can punch that into our calculator. But what if we have log base 2 of 16? If you are using the graphing calculator on your computers should have this graphing calculator available. You would punch in alpha button, window button. It pops up this menu, and then you select number 5. So I'm going to write that in there. Alpha, window, 5. Alpha window 5 gives you this log blank blank. So you could type in log base 2 of 16, and the calculator tells us that it is 4. Now, what if you either have an older graphing calculator that doesn't have this feature, or all you have is this little scientific calculator that doesn't have a log base whatever button. We're going to do something called change of base. I'm going to write this over to the side. I think you should have some space over here. Let's say we have log base b of x. We would do regular log button x divided by regular log button b. And I'm going to put parentheses around those to show you that you have to close your parentheses. So log button, the number that's inside the log, divided by log button base. That's called the change of base formula. It allows you to calculate any logarithm using your calculator. So how would that look in a calculator? We would do log button. Which number should I put in first, the 4 or the 64? The 64, the big number, the number that's in line with the log. So log button 64, close your parentheses, divided by log button 4, close your parentheses. The answer is 3. So I'm going to write that in here. We did log button 64 divided by log button 4. And we got an answer of 3. To find an inverse, you switch the y to an x, and you switch the x to a y. Then you need to get y by itself. Y is currently stuck in this logarithm, so we need to change forms. And it's probably easier if you put the equals x over on the right side, because that's how you're used to seeing the log ride. And then do the log ride. Woo! 3 to the x equals y. The inverse of y equals log base 3 of x is y equals 3 raised to the x. Number 20, there's a couple things to think about here. ln is really log base e. I need to switch my y to x and switch my x to y. Then I need to do the log ride. And for most of us, it's easier to put the equals x on the right side. Start at your e and woo! E to the x equals y minus 3. What should we do now to finish getting y by itself? Add 3 on both sides, so our final answer is e to the x plus 3 equals y, or y equals e to the x plus 3. Try number 21 on your own. It's very, very similar to number 20. Then I only add this because I saw that it was on the assignment and I didn't want you to be completely confused. What if instead of starting with a log, we start with exponential? You'd still switch your x and your y. The y is stuck in the exponent, so we need to change forms. And again, I'm going to put the equals x over on the right side and do the log ride. This time we're changing from exponential to logarithmic. So I'm going to write down log base 4. The next thing I write is the x equals y. And that would be my final answer. So you can find inverses going from log to exponential. You can also find inverses going from exponential to log.